AEE, and it is really the great the time that right now we are to this webinar session, and AEE is giving the good opportunity to connect not only in India but across the world. So I really thanks to AEE initiatives and AEE Western chapter. So with this all, and I really thanks to the all across. I think just I have seen the participants. So just it is on the globe. So I thanks to all the participants just with me. And today I'm going to talk and going to interactive talk to all of you regarding the green hydrogen, which is right now uh, uh, which has a lots of potential to solve not only the energy crisis or energy issues, but apart from that, what the need right now as is the global, as comes to the global greenhouse gas emission. Right? So just right now, just I'm requesting the participants.
Excuse me,
Please
excuse me,
just
everyone,
mute
please
yourself.
mute your microphones.
Sorry.
Hello, somebody's microphone is on, so kindly mute it.
Yeah.
Yeah, please.
Okay. Thanks a lot. So just right now, I'm just going to connect with my slides, right? I think my slide is visible to all.
Yes, it is.
Okay, no issue. Yeah. Yes. So before starting of that, just right now, I'm just going to brief little about what right now the situation in India, right? So this is the data of the 31st March 2022, as per the CEA or the Central the Power Ministry, that right now we are reach up to the 416 gigawatt of our total installed capacity, and just
Excuse me, I think your slides are not moving.
okay, no issue. Just yeah, please just confirm. It is moving, ma'am.
No. I mean, we are just seeing the first slide. That's it.
Okay, no issue. Just again, I'm just going
You can share the complete screen and then use it.
okay. Can it is okay?
Yeah, you can make it in a presentation mode.
Yeah, I have made in the full screen, right? I've made the in full screen.
Yeah, now it is okay.
Now it is changing. Just confirm.
I mean, we can see Indian power scenario 23-24.
No, just I'm changing the slide. This is the one slide. Just I'm changing the slide. Now changes.
No, not yet.
Yes, Bhavna ma'am. Now it is showing the energy mix opportunity.
Yeah, we can see that slide.
Just one and two slides. Just I want to change. So the slide is changing, ma'am.
No, slide is not changing. Why don't you take it in a presentation mode?
Okay. So I think in full screen it is not going to be.
No. You can take it in a presentation mode. That. Yeah, now we can see. Yeah, now the slides are changing.
Okay.
Yeah.
The third, why hydrogen is lucrative solution. It is okay, ma'am?
What we can see is Indian power scenario 23-24.
No, ma'am. Yes, please pardon to all the participants. Please confirm. Now it is changing.
And now we are seeing energy mix opportunity.
Okay. Next one is it is not changing, ma'am.
No, it's not changing.
Okay. So can I do one thing? Just I
Now
can give.
it is now Indian power scenario.
Okay. So what I will do? I'm just going to change the manual. So now it is.
Yeah.
It is visible.
Yes, it is visible.
Now it is changing.
Yeah, it is changing.
Okay. So we can do manage like this. Okay.
Yeah.
Okay.
Yeah, it is changing now.
So yes, all the participants. Right now, I'm just going to talk to you about the total the installed capacity. Right now, with our data of the central electricity, that we have reached to the 416 gigawatt. Right. So with this data, just you see from the table that the coal still it is have the 49%. But I am going to give you the details of just of one decade before. We are in the position that we have the 65 to 70% that the generation is coming from the thermal, right? So now in just of the mid, we have come to the coal is just of 49.3%, right? In the coming of the decade, that I'm going to forecast that this the load what is coming from the fossil fuel, it is also going to be reduced in what we can say the significant amount. And the other part that is about the renewable energies like the solar, wind, this the green hydrogen concept, and some other the wind. So these all are the together giving the higher and higher the generation, right? So just you see from the data of the central electricity right now, the wind, solar, and others, it is going to contribute the 30%, right? So the total this is also of the total of RES is going to be 43%, right? So in this way, just what I'm just going to conclude from here that if we are looking forward for the next decade, it means right 23 to 30, 33 in the just of the 10 years. Right now, it is the best time that the renewable energies are going to be the lead, right? This is the same situation when we are. I'm just going to compare in 2009 when I was in the college of the engineering, and that time the solar was just has take the birth, right? So that time the many what we can say the industries and other peoples or stakeholders they are talking about, it is not going to a alternate solution of the thermal, right? Because that time I have remember the unit cost with the solar is coming to the 13 rupees plus, right? But now situation in just of what just of the 10 years or 12 years, now these solar are very much competitive with the coal, right? As consideration with this relation with the pricing. Okay, but in some other factors also the coal the cost is goes high, right? So in the same way, right now we are in the phase that hydrogen is just going to start the birth, right? And just I'm going here the such more details that this is the right time where the many industries are going giving the more and more emphasis on R&D. They are going to set up with their own the labs, facilitating the things, right? Investing, and they are coming with some great solutions, right? So just I will share the one and two things in this regard. So in the first, just I would like to tell you that the Reliance that is talking about his respected um, MD Mukesh sir has told about they have targeted of 111. 111 means it is very interesting. The thing is about 1 kg of hydrogen would be cost of the $1 in 1 decade. So he has put it this the target, right? Apart from the other ventures like the Renew Power, IOCL, they also have going to do the great investment in this field, in the field of this hydrogen energy, right? Just we have also little bit update that the Germany has little bit some the hydrogen fuels train is also they have started. So one a small just video I just want to share to you that how our country is moving in the direction of the Atmanirbhar Bharat.
Is there sound with this file? Yeah, is there sound with this file? Because we are not able to hear anything.
Apart from the Reliance, some other just right now this week, the Tata still also have they have started the very big assessment that hydrogen gas firing in the blast furnace in the Jamshedpur. So the this is the right way and right the time then many industries are going to lead in the perspective of how they are producing producing and they are going to change the technology what in their periphery what in their system is having, right? So some more examples just right now I'm just going to share to you the Gujarat Gas Limited in the itself in the Surat. They are right now they are doing the blending of hydrogens with the natural gases, right? So this is the right time, and we are hoping that definitely our country will be lead in this platform. But it is not easy, right? There's so many challenges right now we have to face, right? The technology development, right? And the some factors just I'm going to share from now onwards that how this the firing technology is going to be built up, right? As we talk about the system of the furnace, as we talk about the system of the boiler, right? So each the thing I'm just going to explain in the detail. First of all, just I will give you the characteristics of these hydrogens. So it is having the huge amount of the GCB value like the 28,922 kilocalorie per kg. If we are going to compare with the natural gases, then clearly we are getting the more than 2.5 times, right? Apart from that, some other factor, just I would like to show you that if we are just burning of the carbon, right? So 1 kg of carbon, it is going to give you your heat value of 8,084 kilocalorie, right? In the same way, if I'm going to burn of the hydrogen, then it is giving the almost of more than 2.5 times, right? So in this way, this is the comparison based on the heat value. If we see the other opportunity that hydrogen is going to give, that the first and foremost is about the emission. This is the very right now the alarming the time for us, because right now we uh, we are in the situation that we can say that we all are sitting on the fireball, right? So this is the best time that we have to think not only for the development, but how we can save our earth for the futures, right? So in this way, this hydrogen fuel and hydrogen have the potential to solve both the issue, right? So just and little bit give you the more detail about hydrogen features. Just I have mentioned here that it is going to be stored at very high pressure. So this is one, but we can say the challenge for us. And the reactivity is very fast, and oxidation, such like the metal of the lithium, sodium, magnesium, aluminum, and zinc, and the water. So according to that, we have to make the storage, make uh, 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 the 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 system, so that we can transport it. Due to this reason, right now we are not in position to transfer into the bulk. That's why what we are right now doing, we are just doing in the small of the buckets. If we Why this hydrogen is having the so much and promising future fuels, right? So this is what we can say, this is the solution of energy and environmental both, right? So as according to the types of hydrogen, so it is green, gray, blue, pink, and white. So depend upon the generation, these all are coming. If we talk about the green hydrogen, that we are going to generate through our renewable energies or renewable electricity, right? So once again, just I would put the how this method of your hydrogen gases are going to be come up. So the first the thing that we can say, the steam methane reforming. After that, the partial oxidation, autothermal reforming, methanol reforming, pyrolysis, oxidation, reduction of biomass, electrolysis method for the water. So this is the best method, and where we and in the globe, the lots of the research and the lots of the work is going on, right? After that, we have also method for fermentation of the organic material, thermochemical splitting of the water, right? In the details, just I will share you just here one small the setup, because right now I'm really pardon to me that just I have make the small video how the birth of green hydrogen is going to take place through this electrolysis process, right? So this is very simple. We have the one voltage, or we can say the potential will be there, or we will have the small the battery cell, or the source of the electricity, through which and petrol we are going to pass through the water, and through the flowing of the current, the water again it is going to dissociate in the form of the hydrogens and oxygen's bubble. So that is going to be collected on the different part, right? So this is the process that is called your electrolysis method. But here the process and the challenge to get this hydrogen gas is very very tough, right? And the production rate of hydrogen is still very in the lower side, right? So right now the more and more development is going in the way that what type of we can use the catalyst, what type of some research is also going in the way that we can take the cadmiums or the some other materials electrode, so that it is easy, safer and faster generation of hydrogen we can get it, right? So this is what we can see in the phase of the prototype, we can say. Okay, so after this the success of this prototype, then we can scale up, or industry can scale up in the large, right? So this is the small the thing. Now the question is about, if because I belongs, my background is belongs from the boiler, so how we are doing this hydrogen gas firing in the boiler, right? So this is the very interesting and the challenging the phase right now, because suppose we are getting the abundant of the good quantity of the hydrogen, but how, what are the SOPs are there, how we are going to fire this hydrogen in our boiler, right? So just I have made the small the slide for that, in where I will just show you that how this is going to be possible, right? Because the challenge is here that if we compare with the other hydrocarbons, right, then hydrogen is having the huge amount of the heat generation or heat flux per unit of the area, right? So according to that, what happens, your burner design, your swirler design are collection of their metallurgy in such a way that it goes to the copper. So just, yeah, so here just I'm share you in one of the boiler that is going to fire of this hydrogen. So this is the trend of the train, or what we can say the scheme of the firing of hydrogen in the boiler, right? So very sensitive, this hydrogen is very sensitive. When the leakage is there, then use the chances of the explosion, right? So we have the high quality of the detection system that I will explain in the next of the few slides, right? So this is the pathway and this is the scheme where we have, with the help of the good accuracy of the instruments, we can fire in the burners of hydrogen's burner in the boiler. And if it is not going or in idle time, we have also will have the purging system, and this purging system is going to be complete through the nitrogen, right? So by this method, up to till now, we can achieve in practical way 20 to 25% by volume, or we can say in the normal meter cube, 300 to 400 normal meter cube per hour we can achieve it with the pressure of 21 to 25 mmWc. So here just I have mentioned the SOPs of the hydrogen firing in the boiler up to the 40%, but the 20%, 25% we have achieved. Right. So just you can see here the hydrogen gas pressures. We have the safety limits and the safety alarm for that, for safer operation and reliable uses of these hydrogens in the boiler. So high pressure will be tripping will be there at 25 100 mm of WC. In the lower side it is 100, okay, and the gas leak will have the generate the alarm on 400 mm of the WC. So with these facilities we are moving. Now what are the challenges of hydrogen firing, right? As we are looking for the design, so first the thing that is the challenge is we are facing, that is the hydrogen is having the laminar flame speed, which is as compared to what we can say the other hydrocarbon. At already I have explained in that. So it means what it means, it means that if the going to compare with the other hydrocarbon per unit volume or per unit of the area, how much the heat volume is given by the hydrocarbon as compared to the in hydrogen, it is much higher side. The point is that the if we firing with these hydrogens, we can get the high amount of the adiabatic the temperature, and this temperature will have the more than 1100 degrees Celsius, right? So what happens above of the 1050 or 1100 degrees C, your again NOx generation is going to be start, right? And here what we have observed that um, as we are firing with this, so it is coming to approx of the 3 times your generation of the NOx is goes as compared to the hydrocarbon, right? So that also we have to take a challenge, that because we have, as per the norms of the CPCB or a state pollution control board's norms, we have to limit our the SOx and sorry NOx at the level of the 50, right? So that is the real one challenge when we are firing with hydrogen in a boiler. The next is very important, that is uh, the temperature, adiabatic temperature, that is goes to 3960 degree of the Fahrenheit as comparison to the natural gases, where the natural gases will have your 35 18 1000 degrees Fahrenheit. So what happens in this way, that your burner should be the robust, your material definitely we have to choose the up to higher grade of the alloying element also, right? According to that we have to selection of the metallurgy like the chromium and the other molybdenum and the other the composition of materials that we have to select for the using of this hydrogen as a fuel in the burner, right? So these are the right now we are facing the challenges which is coming in the way. We will definitely come over and will have the solution for that. So now just one process outline I have showed for the hydrogen boiler. So we are getting through this through the electrolyzer, and after that we put it in the combustion chamber, right? Then these are going to process of the combustion, and the heat is going to be generated, and this heat is going to utilize for the steam generation, right? So this is the basic schemes I have drawn for that. Now the government is also giving the some much more emphasis, or they have started the green hydrogen mission, right? So just I will tell you about that initiative, but before that I just right now to put you that your safety concern and the safety interlock devices which will be going to help to detect the 0.001% of the leak of the hydrogen, right? Where we are using in the boiler or in the furnace area, right? So just I have mentioned these two instruments will have the highest accuracy of the leak detection, right? So TLG systems and the flame scanners with the ultraviolet or infrared detections no more suitable for that, right? Because these instrument which is going to work on the UP and IR will have the some uh, the limitation, right? So if we go to detect for the hydrogen, then we have little bit move to the other the sensing devices to accurate and fastly give the result. According to that, we can prepare our SOP that stop the firing, and what are the results are came. According to that, we have to purge, we have to clean the system. Other challenges with the one challenges what we are going to how we are going to modulating the firing of hydrogen in the boiler. Other challenges is associated with this green hydrogen itself, that uh, the formation of the through your electrolysis method or steam forming. The two main process of the hydrogen extractions are extremely expensive right now. Okay, so just in few slides I will talk to you the costing of right now what is, because definitely this question you have in your mind that what right now the cost of the production of per kg of hydrogen, right? So just I will share to you. Apart from that, the storage is one the big challenge, because you have to store at a very high pressure for that. Compared to the gas, the hydrogen leaks a smell which may any leakage detection almost impossible, right? So that's why we have to use very high and very high accuracy of equipment when the some leakages are going in a way we can easily trace out, check it, and isolate it. Hydrogen also presents challenge when the considering moving it the large quantity that I have told to you. That's why what right now we are doing in the transport, we are doing in the small batches. As drawback, we can see of hydrogen as a fuel, then it is the main important the thing is about the existence and the infrastructure. It is also required to deal with the same, right? So in this the way, if you see the production, so one, if you talk about the green hydrogen production, then we are going to generate the electricity through the renewable energy systems. After that, we will do the electrolysis method, and we are going to generate the hydrogen. Next is about if we have the CO2 capture system, then with application of this hydrogen, we are going to form the synthesis fuels. If we are going to mix with the N2, then this is going to generate the ammonia. So that's why it is called the green ammonia, right? And the transportation by shipping by trucks or through your pipelines, we are going to transport, and the users is your almost all of the industries are going to use in their specific way. Some were directly used as the raw uh, product. For some they are using the source of energy. Now this is the important thing about the purity of the hydrogen, because what happens, uh, suppose there is a minor or minor 0.01% of the leak or impurities will be there or moisture will be there, use the chances of use amount of the explosion may that take place, right? So that's why the regular we have to take the sample, regular we have to monitoring the system, dedicated monitoring systems we have to place uh, in that the close the system, so that any radiation or any leakages are there, we can easily trace out the systems and make it safe. Just I talk to you regarding the cost of the hydrogen generation, right? So if just I have told now that in 2010, what was the cost, right? So that time it is going to cost your just I will tell you the cost is your hydrogen for per megawatt of generation, that was the 600 US dollar, right? Our per kg of hydrogen generation cost of hydrogen per kg, that was the 24, right? So right now we we are having the cost is lump sum of the 10 to 12 dollar per kg, which we have to target on the next the decade. We have to reduce on the larger scale of 1.5 to $2, right? So this is right now the going to cost of the production of the hydrogen. Yes. So the government of India is also have the great missions to promote and sustain more development in the field of the green hydrogen missions, so that they have published, they have maintained the policy for that. So this policy is going to create the favorable conditions to promote the uses, promote the more development in, and make as a energy hub in the green hydrogen field. So just few of the clause just I'm going to discuss to all, that manufacturing of the green hydrogen or ammonia, the renewable energy plant shall be given the connectivity to grid on the priority basis to avoid any procedural delays. So that the provision they have made. And apart from that, the some relaxation is also going in the format of the taxation and benefit of renewable purchase obligation. That is your RPO will grant the initiative of the hydrogen and green hydrogen manufacturer and distribution licensing to consumption of the green power. So these are the some steps is going on, which will definitely in there are much detail uh, uh, pathway are mentioned by the government of India to promote of this green hydrogen mission. So right now I'm just going to just a little bit I have just to touch on that. Now this is one important thing. This is very important, that what are the lucrative solution when we are using the green hydrogens or hydrogen gas. So simply just I tell to you, if 1 kg of we are using the green hydrogens or hydrogen gases, then we are able to generate the 33 kilowatt hour, or in simple way we can say by 1 kg of hydrogen gas we can able to generate of 33 units, right? So this is the this is the one important the benefit and opportunity by using this hydrogen gas. Yes, the second one, as I have started with this, the theme of this webinar, that is about the energy security or energy mix, right? So energy security is going to provide us through the steps of the more and more uses of this hydrogen energy, so that what happens, the load on the thermal and other sources are little bit diminished, and R by P. So R by P is your reserve versus production for the coal is just right now it is estimated for availability for it is next of the 35 to 40 years, right? So that's why I am much more giving the emphasis that we are at the bottom of the corner, or just we are edge of the corner, right? So here we have to take the initiative, and we have to fast to run, not only in the uses of the electricity or generation, but also for the our future also, right? So it is also going to provide you the energy security for Atmanirbhar Bharat. More detail I just I want to share to you regarding the development of hydrogen energy in India. So the some research of the different part of the labs is going on, right? In somewhere they are using the work is going on the method of the electrolysis. Somewhere they are using the how we can rate or increase the rate of the production of this property. So this way the all the development are just in their phases, like ICIMFR, Dhanbad, PSUs, Mahindra and Mahindra, IIT Kharagpur, in some research work for hydrogen storage in the carbon material in IIT Madras, IIT Chennai is also going on. Right? So the now we reach to the part of the conclusion that hydrogen storage is still the major issue of the concern. Lots of work is still we are we are in doing and in process. So lot of the things are still the development, usage, reliability are in the pipeline. So hope we will coming time we will get the latest development of usage of hydrogen in the coming future, right? So thank you to all for attending this webinar. Apart from that, if you have any query, then you can also directly mail to me. Just I will show my mail ID at end of this session, right? So if you have any question regarding this topic, so please, anybody, please you can put your question.
Yeah. So there are many questions, but before that, I also want to ask a question. Like we see, I mean, can the question is like, while hydrogen energy is very much promising, so can we replace it totally with thermal power plants? I mean, will that happen someday?
Yes, it is very interesting question because in the morning the same the question is wondering in my mind also, that in the coming future what is going to be happen after that in after the 2035 or 2040, that right now we are using our in the home the LPG cylinder, right? So might be possibility if we reach to the that level of the technology, then whole of the what we can say the systems of that LPG is going to replace with the hydrogen cylinder itself. So this kind of the possibilities are there. Okay, so yes, we can hope, because this is really, it is very promising. The technology is there, huge amount of the bundle of the energy is associated with there, but the thing is that how we are going to connect the each the dot or each the segment or link is now the challenge, but we will succeed.
Okay. Thank you so much. And that was a wonderful presentation. I mean, it was totally new, I suppose, for all the participants also. And there are other questions also, which I will be reading and you can answer.
Please.
So one of the question is, I'm not sure who has asked this, but in which Indian plant fired with H2 gas? Yes, Mr. Dinana, did you get the question?
Sorry, I'm not got your
Yeah.
what we can say
In
question.
which,
Please repeat
in
me.
which of the Indian plant H2 gas has been fired is the question.
Yeah, right now, not in the single segment, in the lots of the segment or in part of the India, I can name the few one. In just in the Surat itself, in the LNT or in IOCL, they are have the setups, and right now they are just dealing with the 4 to 5 kg of the hydrogens as a prototype, right? So in this way, many in DRDO also. Okay, uh, I cannot tell the open name to all, right?
Hmm.
But the research is going on, the projects are going on. When the result will come, definitely it is open to all, and we will get the names, right? But the work is going on everywhere. 5 to 6 kg uh, per hour, the consumption and the firing is right now the achieved.
Okay. Yeah. I hope that answers this question. And another question is boiler metallurgy part and safety of boiler and leakages. I mean, that's what is the concern of one of the participant.
Absolutely, absolutely. Because yes, the question is very valid. Because this is what we can say: the laminar flame is going to be rapid increase, right? So what happens? The huge amount of energy is going to be liberated, right? So the if you are using in the boiler, then your burner or your furnace, the metallurgy should be upgraded, right? The second question is regarding the safety. Yes, it is very important, because in the slide also, in presentation also, I have discussed that the what are the traditional method like the UV or IR, that method is not going to compatible with this hydrogen, right? Because here 0.001% of the leakage is going to create the disaster, right? So that's why we have to adopt very high accuracy the systems that I have named it, the TLD, the systems are there, right? But if we increase on the larger scale, that system also we have to develop to cope up and to prevent, to safer of the operation of the plant and the people.
Yeah. Thank you, Mr. Dinanath. The question is, what is per megawatt installed cost?
Per megawatt right now, just it is if we talk in the dollar, so right now it is just I have shared in the PPT also, so $24 right now it is coming, right? So that's why we have aimed, and the Reliance Industries, the MD Sri Mukesh Bhai, they have given the mantra that we have to 111, means 1 kg of hydrogen, the cost would be the $1 in within the 1 decade.
Okay. Yeah, thank you. Another question is from Mr. Padu Padmanabhan, and his question is, from a technical point of view, can an existing coal-fired industrial water tube boiler be converted to operate fully on hydrogen, and would the boiler have to be re-rated? Also, what are the furnace design changes required to accommodate the difference in the nature of heat transfer rates between coal firing and hydrogen gas generation?
Absolutely, I thanks to concern of these questions. Absolutely, there are lots of the changes we have to need. Not only the arrangement design of the boiler, but apart from the operational philosophies, also we have to change according to that. Because when you are giving the huge amount of the heat in the furnace, your superheater, the temperature is also going to be suited, right? So that the things we have to see in the feasibility, that uh, in each boiler how much amount of hydrogen proportionate is going to be used as a safety, right? Okay, so suppose just I will tell you, one boiler is having a capacity of 100 ton or 500 ton, right? So according to that, how much kg of hydrogen per hour we can pour in a boiler, and boiler is reliable to uh, get that amount efficiently, and there is no any change or there is no any abnormality in the operation. So that we have to see, that we have to study based on the heat volume, heat ability, heat flux, right? Furnace area, heating surface area. So all the huge amount of the calculation is based on that. We can say that for a particular boiler, these amounts are optimum. We can use it, right? Because the sir has talked about the old boiler, right? So in the old boiler means we can not goes to the higher and higher. So how much the limiting or how much the optimum amount we can consume continuously without affecting the factor of the operation and reliability and safety of the boiler.
Yeah. Mr. Padmanabhan, I hope that answers your question.
I think so. Apart from safety, can you hear me?
Yeah, yes, sir. Yes, sir.
Apart from safety, the question really was in an existing coal-fired boiler, industrial boiler, water tube boiler, if one were to change from coal to hydrogen, as you rightly said, the heat transfer rates are very, very different in both. Obviously, hydrogen has a much higher transference rate. Also, I think hydrogen is more luminous, so the radiation heat transfer would be high. And as you said, the adiabatic temperature is also much higher, meaning your radiation heat transfer would be facilitated that way. So the internals of the boiler would change considerably in terms of superheat area, in terms of convection area, and so on. So, as also the fact that hydrogen results only in water vapor, so corrosion rates also would be different. Metallurgy, as you said, would be different. So the economics of doing so would be much different and would be difficult to justify. So I just wanted to get a sense whether a coal-fired industrial or utility boiler can be economically changed to hydrogen. What is your thinking about that?
Definitely, sir. I'm some point I agree with you, but as the firing concern of as you told, because here this hydrogen is absence of the carbon, so the combustion is going to be take place. That is going to in the laminar or adiabatic the methods, right? So this heat amount is definitely going to impact the operation and the performance, right? So according to that, we have to think of that. Other factor is also, and what the main thing is about, because we are going to discuss about the oil boiler, right? So how much amount, how much we can add the quantity of hydrogen, because what happens, we are just simple one situation I'm just going to explain and correlating with this the thing that we are firing with hydrogen. What happens, your superheater temperature will increase, but we have the limitation of the temperature flow, right, sir? So how much the design is already going to provide with the temperature line, the capacity and the flow, and according to that, what amount of optimum value of hydrogen consumption we can take it safely. So based on that, we can do the optimum cost calculation. So this way we can evaluate the answer and we can proceed that what are the feasibility in that, because every boiler is what we can say the significant different in the design, right? So based on that, their possibility and availability of the margins available on the terms of the heat flux, in the terms of the cooling media, in terms of the water holding volume, then we can say, I think it is.
Yes. Again, next question is, what is okay cost of hydrogen gas? I think we have already it was answered.
Yeah, already I have told that right now it is the costing only for the production on a pilot basis, that is coming to the $24 per kg.
So one more question is there, that is, can we fire it on in hydrogen gas turbine?
Yeah, yes, it is also because somewhere I have already explained that we are some part of the 20% we are going to mix with the natural gas, and firing is also in what we can say in the boiler or furnace, or what we can say in the gas turbine also.
And last question, that is, what is the heat value of hydrogen? I think that
It is already I have mentioned in the PPT. It is 28,922 kilocalorie per kg of the hydrogen. So this is the value of based on the GCV.
So, like, this was all the questions that we have. And thank you once again, Mr. Dinanath. And thank you, participants, for many of you are now attending our webinars regularly. So thank you for this response. And we will keep on bringing in new topics. You can also send us email suggesting us for new topics as per your interest. And all our these recordings, many of you have asked for presentations, but all these recordings are all available on our LinkedIn page. So I have given that in the chat box. LinkedIn page has been given. And if any one of you have any questions regarding membership, you may ask now. Let me see. Yeah, Ashish. Yeah, Ashish, you may ask your question, please.
Roshan sir, is there any power plant available in the world about hydrogen, using hydrogen fuel? Able to hear me, sir?
Yes, Ashish. Right now, what we can say, it is very newly filled, right? Just we have got the information and successful the trial completed of hydrogen fuel in the railway in the Germany, right? In the as concern of the questions related to the power plant, not the fully but partially, like the 10%, 20%, the fuel firing is going and achieving in the lots of the power plants in the globe, right? But not 100%.
Okay, sir. Okay.
So I think.
I think excuse me, I have missed one more question. So that was from Mr. Sanjeev Jain. Is the green hydrogen generation from RE power commercially viable option? As RE is infirm, I mean, I am not clear with this question. I will ask him to speak about it.
Yeah,
Mr.
please.
Sanjeev Jain, can you speak? Yeah. Yeah, Mr. Sanjeev Jain, can you speak, please, regarding your question, because it's not clear. I think he's having some problem, or probably he left. So thank you very much. Thank you, participants, and thank you, Mr. Dinanath, once again for giving your excellent presentation on future energy, that is hydrogen energy. Thank you. See you all on first Friday of, second Friday of the May, that is 12th of May. Thank you.
Thank you, and thank you to all the part of the audience. Right? If you have any the query regarding the details of the hydrogen, already I have mentioned my mail ID, so you can directly mail to AEE Western chapter, or directly you can mail to me also. Right? So thank you, and have a great learning. Thank you.
Thank you. Thank you. Mm.